Hi, this is Roopa Prasad, Assistant Professor, Department of Computer Applications, MITS College. Okay, so today we are going to discuss the topic called as DIFFIE HELLMAN Key Exchange. Okay, basically this is algorithm. So first we see that what are the contents in this presentation. First we are going to discuss about the introduction part, then we go for the algorithm, then we go for one type of attack that is called as a man in the middle attack. Okay. So, coming to this introduction, this Diffie-Hellman key exchange is an public key algorithm. Okay, it is a public key algorithm. So, this algorithm has been given by Diffie and Hellman, two persons, Diffie and Hellman. And this is called as a public key cryptography that defines public key cryptography, and this is referred as Diffie-Hellman key exchange algorithm. Okay, so what is the main purpose of this algorithm is it enables two users to securely exchange a key that can be used for subsequent symmetric encryption of messages. Okay, as we have already discussed, there are two types of cryptographic algorithms are there, symmetric as well as asymmetric. In symmetric cryptography, what happens? Only one key is used to perform encryption as well as a decryption. Whereas in asymmetric key cryptographic algorithm, we are using a pair of keys. One is called as a private key and one is called as a public key. If we encrypt the message by using the private key, by using the opposite key only, we have to decrypt the message. Okay. For symmetric encryption, what happens? There is only one key will be there. Encryption and decryption will be done by using the same key. Okay, so in order to perform the symmetric encryption, what the two users has to do means first they have to exchange a key. First they have to exchange the key so that they can perform the symmetric encryption of the messages. So in order to exchange that key should be securely exchanged. That key should be securely exchanged. In order to exchange that key, we are going to use an algorithm called as a Diffie-Hellman key exchange algorithm. It is the most popular public key algorithm which is used to exchange the secret key between the two users that are going to perform the symmetric encryption. Okay, and this Diffie-Hellman algorithm mainly depends on the effectiveness on the difficulty of computing discrete algorithms. Okay, so we will discuss. Okay, in this algorithm, we are mainly using two publicly known numbers. Two publicly known numbers that we call it as a prime number q. We are going to take a prime number q and we are going to take an integer alpha which is a primitive root of q, which is a primitive root of prime number. Okay, suppose that users A and B wish to share a key. Suppose A wants to communicate with B. That means A and B are going to be communicated. So, and they want to create a shared key. That is a secret key. Using this shared key only, they are going to perform their transmission of messages using the symmetric cryptography. Okay. For that purpose, what the A is going to do means A is going to generate one private key that is a random number that is called as XA. Here we are terming the private key as XA and public key as YA. Okay, so this algorithm is a public key algorithm which is used to generate the secret key, which is used to generate the shared key, or we can call it as a symmetric key, which is used for the symmetric cryptography. Okay, so A is going to select a random integer called as XA, and what is the condition here means this XA should be less than Q. Q is a prime number. Okay, and by using this XA, he is going to compute YA, which is a public key. YA equal to alpha to the power of XA mod Q. Okay, and B also selects one random integer called as XB, and this XB should be less than Q. And by using this XB, he is going to compute YB. YB is a public key. YB equal to alpha XB mod Q. Alpha to the power of XB mod Q. Okay, and so each will compute their private key and public key. So XA is a A's private key and YA is a corresponding A's public key. And similarly for the B. Now user A computes a key K equal to YB, which is the public key of B, to the power of XA mod Q. And user B also computes the key K equal to YA to the power of XB mod Q, and these two calculations produce the identical results. That is the importance of this algorithm. Okay, now A is computing separately and B is computing separately, but key can be computed combinedly. By using the public key of B, A computes a key, and by using the public key of A, B computes a key. Whereas these two calculations will produce the identical results. Now we see that Diffie-Hellman key exchange in this particular diagram. So Alice is a sender, whereas the Bob is a receiver. Okay, so Alice and Bob share a prime number. So these two will use the same prime number and the same integer. So Q is a prime number. He is going to choose. Alice is going to choose a prime number Q, and Bob is also going to use a prime number Q, which is a same prime number that has to be shared between the Alice and Bob. Okay, and they are going to choose an integer called as alpha. And what is the condition here? Alpha should be less than Q, and alpha is a primitive root of Q. That is the condition we have to check. Okay, we have to share a prime number Q and an integer alpha. This alpha should be less than Q, less than the prime number, and this alpha is a primitive root of Q. Okay, then Alice generates his own private key, that is XA, such that XA is less than Q. Meanwhile, Bob is also generating the private key XB, such that XB is less than Q. After that, Alice is going to calculate the public key. By using its private key, he is going to calculate the public key. So YA equal to alpha XA mod Q, alpha to the power of XA mod Q. Meanwhile, Bob is also calculating its public key. YB equal to alpha to the power of XB mod Q. Okay, after calculating the public key, the Alice is going to announce its public key, and Bob is going to announce his public key called as YB. By taking the Alice public key YA, Bob is going to calculate the key. Bob is going to calculate the key, and by taking the public key of Bob, Alice is going to calculate the key, same key. So, how Alice is going to calculate means K equal to YB, that is a public key of B to the power of XA, which is the Alice private key mod Q. And how the Bob is going to calculate the key is K equal to YA, which is the public key of Alice to the power of XB, which is the private key of Bob mod Q. Okay, what is the importance of this peculiarity about this algorithm is both keys are same. Okay, they will give you the identical results, and by using this K key, they can go for the symmetric encryption. Okay, so and one more thing we have to discuss is this Diffie-Hellman key exchange is insecure. So why we are calling it as insecure means it is insecure against one type of attack that is called as a man in the middle attack. Okay, so that we will discuss by using the diagram. See here. Okay, this Darth is a middleman. This Darth is a middleman, and the communication has to be done between the Alice and Bob. Okay, this Alice and Bob are going to communicate. For that purpose, they are going to create a shared key. Okay, and this Darth is middleman. So what happens and how this algorithm flows? Alice is going to take her private key, and by using the private key, she is going to calculate the public key, and Bob is going to have his own private key, and by using the private key, he is going to calculate the public key. Then this public key of Alice is announced, and public key of Bob is announced. By using that, they are going to calculate the shared key. See here, we'll see what happens. So Alias is going to select her private key called as XA, and by using XA, she is going to calculate YA. Okay, then this YA is publicly announced. What Dath is going to do, this is a man in the middle. So this Dath is going to calculate his own private key and public key. He is going to choose two private keys. One is for to give to Alice, and one is to give Bob. So he is going to choose two private keys called as XD1 and XD2, and by using these two keys, he is going to calculate YD1 and YD2, both which are the public keys. So whenever the Alice is going to announce her private public key, that key will be captured by that. Okay, and instead of this key, that is XA, which is the public key of Alice, he is going to distribute YD1, which is a public key of that. Okay, so what Bob thinks means that is a public key of A only. He thought that is the public key of A. Okay, and similarly, that B is going to calculate, choose the private key, and he is going to calculate the public key, and that public key is announced. This public key will be captured by that. In addition to this public key, he is going to announce his own public key, that is called as X by D2. Okay, so what Alice will get means the public key of that, and Bob also gets the public key of that. Okay, by using these public keys, they are going to calculate the key K1, and this also K2 will be calculated by Alice, and K1 will be calculated by D1. These two keys are similar. These two keys are similar. Whereas this shared key, now that is having the original keys. So he is going to calculate the keys. Okay. So this key is in between Alice and that. Okay. And this key is in between Bob and that. Okay. Actually, the communication has to be done between Alice and Bob by using the a key called as K. But what happens here, that in the middle, he is going to create his own key, and he is having the communication between the Alice and that. Okay, and Bob. So that attack, we are calling it as man in the middle attack. So whatever the conversation that is going on between Alice and Bob, by using the symmetry key, that can be viewed by that, because he also knows the key. That we call it as a man in the middle attack. And this material is prepared by using these textbooks. And if you have any queries, you can give your queries to this form. Hope you understand. Thank you.